So in this video, we're looking at the mean value theorem. So Rolle's theorem can actually be used to prove this specific theorem called the mean value theorem. And what the mean value theorem tells us that if f is continuous on the closed interval from a to b and differentiable on that open interval, then there exists a number in that interval such that the derivative is equal to f of b minus f of a over b minus a. I want y'all to look at this formula. Isn't this a slope? If we're talking about a and b, these are initial, or final minus initial, minus initial. We got 2 points. We've got a, f of a, right? That's 1 point. And we've got b, f of b. Remember, anytime you see f of something, that's just the y value associated with that x. So we got a, f of a, b, f of b. So to find the slope equals y2 minus y1, f of b minus f of a, over x2 minus x1, b minus a. That's just the slope of the line that goes through the endpoints. So what the mean value theorem is, it tells you that somewhere in the interior between a and b, that there's a point whose horizontal tangent line is parallel to the secant line that goes through the endpoints. A and B. So I've got oh, that's awful. I've got a secant line that goes through both of them, okay? Then somewhere in here, there is a point that has, that's awful too. There's a point that has the same slope that is parallel. There may be more than one, right? But there's definitely going to be one. This doesn't guarantee the existence of more than one, but it does say that there is at least one. And we can use this now to show that for a function, there is some value that does have indeed this slope. So if we're looking at f of x equals 5 minus 4 over x, we're going to plug in the a and the b. 4 minus 1 is the, well, not 4 minus 1. The point is 1, 4, right? Those are the endpoints. So this is x equals 1. This is x equals 4. So what I'm saying is f of 4 minus f of 1. So endpoint minus the endpoint over the x value, 4 minus 1. Well, we need to figure out what f of 4 is. Well, let's just do this. F of 4 is 4. If I plug in 4, I get 4 divided by 4 is 1. 5 minus 1 is 4. If I plug in 1, 4 divided by 1 is 4. 5 minus 4 is 1. 4 minus 1 is 3. On the bottom, I have 4 minus 1, which is 3. I get the slope is equal to 1. Now, this definitely satisfies the conditions of the mean value theorem. So, what are we going to say? We know that f is continuous, and we know that it's completely differentiable on the open interval, so we can use these things. So that means that there exists at least one number in C, or one number C, in that interval from 1 to 4, such that the derivative is equal to the slope of that secant line, which was 1. So we have 4 over x squared equals 1. Why 4 over x squared? Because our original equation is what? 5 minus 4 over x. So we take the derivative of that. F prime equals, the derivative of 5 is 0. The derivative of negative 4 over x is positive 4 over x squared. If you're not sure about that, think about this. That just is negative 4x to the negative 1, right? Multiply negative 1 times negative 4 is positive 4x. Decrease that by 1, that becomes negative 2, which is 4 over x squared. You don't have to believe it. I just showed it. So if we have 4 over x squared equals 1, we multiply both sides by x squared. We get x squared equals 4. Take the square root of both sides, we get plus or minus the square root of 4, which is plus or minus 2. So in that interval, we can show for sure that there is a secant line that goes through 1, 1 and 4, 4, and that there's a line that goes through 2, 3 that share those exact things, and this is a horizontal tangent line, or not a horizontal tangent, just a tangent line. It is the slope of that function at that point. Now, there is another form of the mean value theorem, which tells us that if f is continuous and differentiable on AB, then there is a number C in there such that f of B equals f of A plus B minus A times f prime. This is just algebra, y'all. This is the exact same formula. F prime C equals f of B minus f of A over B minus A. So I'm going to multiply B minus A times both sides. B minus A. That gives us the B minus A times f prime of C. I'm going to add f of A to both sides. So plus f of A. That goes away. I just have f of B equals that. So it's just algebraically manipulating it. So if you have any questions, and by the way, this will pop up a little bit later. We'll see. But if you have any questions about it right now, go ahead and shoot me a remind or ask a question in class.